Right, back again then. Going to do some testing on the board that we built last time. Basically, we need to check all the power supplies are correct. While you were away, I did go over the entire board with a magnifying glass just to check for any solder bridges and that sort of thing. It's always a good procedure when you've got a board that you've just soldered. Glad to report everything was absolutely fine. Right, so the first thing to do, I think what we'll do, we'll check all the ICs have got the grounds in the right place. Fortunately, all of these, the smaller ICs, all seem to follow the normal TTL convention, where the grounds in the bottom left-hand corner and the powers in the top right-hand, so we can find them pretty easy. Now, I'll just the ground. Just an easy point to get to. It's on the end of these two capacitors. So I'm just going to clip one end of my meter on there. I've got a meter on ohms. Let's get the pin. Check the first one here. Right, so we've got a reading of 0 on the meter there. Now that should be the same for all of them. So I'll just work my way along. Right, so far. Okay. Right, those are okay. Let's just check these ones. Well, that looks good. The ground on the processor is on pin 2. Okay. And the ground on the 8212, which is the I/O, is on pin 12, which would be that one. Right, it's great. Right, all the grounds are in the right place, which is a really good start. The next thing you really need to check before you put any power on any board is to make sure you've got no shorts. So what I'll do is the incoming 5 volt starts off on this regulator, so I'll just probe in there. Yeah, that value is actually rising. The reason it's just charging up a capacitor, but clearly it's not short. The plus 16 volt is at the base of this resistor here. Okay, that one looks alright. And the minus 16 volt is on the base of there. Right, everything looks fairly safe, so that's good news anyway. I put some power on this just before I started recording, just to make sure we weren't going to have a bit of magic smoke on here. One slight problem, the Zener diode that's used for the plus 12 volt. If you look at have a quick look at the circuit. Here we go. We've got plus 16 volt coming in here, goes through a 33 ohm resistor. That's the 12 volt Zener diode, and there's just a capacitor there. Now clearly the way this works, to pull that down to 12 volt at that point, it's dropping 4 volt across this 33 ohm resistor, so there's a fair bit of current running down there. Now of course normally you'd have load on the circuit here, so some of the current will go off in this direction. Unfortunately at the moment the only place that 12 volt goes to is the processor. We've not got the processor plugged in, so we've got no current flowing, so all the current is flowing down through this poor old Zener diode. It's only 1 watt. Consequently it was getting rather hot. I actually sort of did a few calculations. I think it was actually dissipating about 1.4 watt, which for a 1 watt Zener was a little bit over the top. I did some, even the Intel say the processor draws round about sort of between 40 and 70 milliamps when it's running, and even, you know, that all taken into account, it was still, you know, it was just about rated correctly. But what I've done, look at there, I've actually put another Zener diode in parallel with the original, so we've actually got a potential sort of 2-watt dissipation there if we, you know, just if we need it. And what I've also done is I've turned down the plus 16 volt supply to I think I've got it at 13 volt at the moment, I think, just to stop this getting hot while we're testing. Otherwise we'll have fried Zener diodes on our hands. Right, so next stage, let's set the meter down to volts. We'll click back on the ground again, and we'll check our incoming voltages. I'll plug it in. Right, we should have power on the board now. Now our incoming plus 8 volt will be here, and there it is. That's fine. Our incoming 16 volt should be here, but as I said, I've turned that down at the moment to 13. So once I've got the processor in, I'll turn it up again. Now the incoming minus 16 comes in here. There it is. Thought that had disappeared then for a minute. Right, okay, so we know they're all there. The next thing to do is to check on the Zeners that we're actually getting a regulated voltage. So we'll check out on C10 here. This should give us our plus 12 volt, which it is now. And, you know, all Zener's doing quite a good job now. And the minus 5 volt should be here, which it is. Right, so all our actual power supply rails going to the board are okay. What we need to do now is actually make sure that those power supply rails are going to the right places. Because obviously if we plug the chips into this and the rails are in the wrong place, it's going to make a horrible mess of it. And these sort of tri-state buffers that live in these sockets here are becoming increasingly rare, and we don't want to wreck them. Otherwise we're going to be in trouble there. Right, so as I said, that the plus 5 volt is going to be in the top right hand corner. So we'll just work our way along like I did with the ground. So we should find 5 volt here, which we do. That's 5 volt. Again, it's fine. That one's fine. That one's fine. That one's fine. Yep. Okay. Okay. It's okay. More in the end. Right, they're all okay. The ones up here. Yep. Right. Okay. Right, the processor's got 3 rails on it. It's got minus 5, plus 5 and plus 12. We've already found the ground just now, but the minus 5 volt is on 11. So if I go... That's interesting. Ah, there it is. Right, there's the one. So I must have miscounted my pins there, I think. Right, there's the minus 5 volt. The plus 5 volts on 20, which is there. Oh, sorry, that's not there. It's there, isn't it? Right, that's plus 5. The last one we want to find is the plus 12, which is on 28. Right, there you go. Counting got a bit better on that one, didn't it? There's also some pull-up resistors to 12 volts, which terminate on pins 15 and 22. So if we look at pin 22, we should see 12 volt again, which we do, and we should see it on 15 as well. There it is. Right, okay, so that one's fine. The 8212 input output chip, that's got its +5 on pin 24. It's anyone we need to check on that one. Right, there we go. Right, so that looks good. So all of our ICs have actually got the right power rails now. So at least it's safe to plug everything in. What I'm going to do, I'm going to put the well, I'm going to turn the power off first, obviously. What we'll do is I'll put all the TTL ICs in first, and then we'll power it up again, and then see, make sure everything's okay, and we'll see how we go from there. Right, okay, so what I'll do, I'll just put this is a 74LS04, I'm going to stick that into socket M, which is this one here. That's got to go in there. Right, you'll notice that if you look at the end of that IC, oh, there we go, all the legs are really splayed out. You'll never get it in the socket like that, so the best way to do it is if you put it on the bench, just gently push down on it and do the thing on the other side. Right, and make sure you've got pin 1 in the right place. There's a little notch on the end of the IC, which hopefully you can see. Some ICs have got a little dot on them, but you know, either way, that's pin 1. And we'll just line him up with the socket carefully. Make sure all the legs are in. Gently push him down. See, that's clicked quite well. And what you need to do really after that is just look from the end of the board, make sure none of the legs are sticking out or anything like that. That one looks absolutely fine. Right, I'll go ahead and put the other ones in there. Right, okay, got all the TTL chips in now. I powered it up, nothing happened, everything was fine. One thing I did check before, though, which seemed a little bit odd, these two chips here, P and Q, which is meant to be a 7404 and a 74123. I managed to get a 74123, but I could only find a 74LS04. Now I checked the clock, and there seemed to be absolutely nothing happening at all. This is the 74LS04 that I had in there. It seemed completely dead. Luckily, at work, I had a really old 7404 in the drawer. I didn't know if it worked or not. I've plugged that in, and now amazingly it's actually working. I can actually show you it running. I'll just shift the camera over so you can see the counter. Let's power it up. Right, here we go. Clipping on. Right, here we go. Oh, right, there you go. There's your 2 megahertz. It also comes out down here as well. Oops. There we go. Right, so that's running. Off that again. So that's a bit interesting. I don't quite know what happened there. Whether there's some sort of extra capacitance in the LS chip or not, I don't know. So, or it's blown up, of course. So I'll need to look into that. But anyway, it's working. What I'll do now, I'll put the processor in the 8212, and then that should pretty much button it up. Just be careful when you put these two chips in, because they're CMOS. And obviously there's a chance of damaging them with static, so make sure you touch something grounded, or preferably wear a sort of grounded wrist strap while you're putting these in, just in case. Right, okay. Right, got them both in. Processor's in there, 8212 is in there. That's about it, I think. I can't really do much more till we sort of plug it into the system. I think what I'll do, we'll leave it till we got all the other boards going, and then see where we go from there. I mean, we may have to do more diagnostics on this board, but so far it looks okay. So that'll do it for now. We'll see you on the next one.